Good morning. The topic I'm going to take is K-means clustering in machine learning. Here we'll see about the numerical example of for the K-means algorithm and what are the steps we will be implementing by using K-means, and also the data visualization method for K-means algorithm by using the Orange software. So K-means algorithm is a unsupervised learning algorithm that is used to solve the clustering problems in machine learning or in the data science. So K-means clustering is an unsupervised learning algorithm which groups the unlabeled data set into different clusters. So again, it is an iterative algorithm that divides the unlabeled data set into K different clusters in such a way that each data set belongs only one group that has similar properties. So it depends on the centroid algorithm where each cluster is associated with a centroid. The main algorithm of the the main aim of the K-means is to minimize the sum of distance between the data point and their correspondence clusters. The algorithm takes the unlabeled dataset as an input, divide the dataset into K number of clusters, and repeat the process until it does not find the best clusters. The value of K should be predetermined in the algorithm. So we'll see about how does the K-means algorithm works. So first, we have to take the mean value and find the nearest to the mean and put it in the cluster. And we have to repeat step 1 and 2 until the mean gets same. So here we have to take, for the given data points, we have to take the mean value and then we have to find the nearest value of the given mean. And if it is nearer, then we will put it in the cluster. If it is larger, then we will put it in the other cluster. So again, we have to remember that we have to give the value of K. So here, this is a numerical example for K-means. Here, S is the data set where it has a 10 data points, 2, 3, 4, 10, 11, 12, 20, 25, and 30. The K value here is 2, which means we have to split the data points into 2 clusters. So again, we will take we will take any 2 random variable, say it as M1 equal 4 and M2 equal 12. So here the value 4 and the value 12 is taken as a random variable where we'll consider this as a mean for the whole data set and we'll find out the difference. So the step 2 is find the nearest to the mean and put it in the cluster. So here we will find out the nearest to the mean. So here the value 2 will take the value 2 will take the value 2 and compare with the mean value 4 and the difference will be 2. And again 3 with 4, the difference will be 1. The difference between 4 and 4 is 0 and the difference between 10 and 12 is 6. So here comparatively 2, 3, 4, the difference is very small. So we will put it in the another cluster and here the cluster name is K1 equal K1. So again for the second random value that is 12, what we will do is we will do the same, that is we will do the we'll find the difference between the data point with that of the mean value. Here 2 minus 12 is 10. So here when compared to the top the 4, the value 4, the difference is much higher than the 4 value. So we'll not consider the value 2, 3 and 4. While considering the value 10, the difference is 2. So for the value of 4, the difference is 6. So the value of 10 is very near to the 12. So we'll put it in the other cluster. Same thing we'll do for the rest of the data points. And we have divided the data points into 2 clusters. Now we have to find out the mean for the new clusters K1 and K2. Here M1 equal 2 plus 3 plus 4 divided by 3, which is the mean, which will give the mean value 3. And here for K2, the mean value is 18. So here again we have to repeat the step 1 and 2 until the mean is same. So again we have found the mean value. Then we have to find out the nearest value of the mean. So K1, K2. Here we have to calculate the mean value. Again the new mean value is 5 and 20. Again we have to calculate the distance with the mean and the cluster values and put it in the 2 clusters, that is K1 and K2. for the new generated K1 and K2 clusters, we have to find out the mean values, which is 7 and 25. Here, we have to find out the difference for the mean value 7 for the data points and 25 for the data points, and the nearest, the value which are nearest, we'll put it in the cluster. The thing is that here the value of K1 and K2, here the value of K1 and K2, that is the cluster values are same. So we have to stop clustering. So which means that we are getting the same cluster and the mean is also the same, and so we have to stop the clustering. So this is a numerical example for the k-means. This is how the data points are clustered by using the mean value. So now we'll see about the data visualization of this k-means by using the software Orange. Here the Orange is a open source data visualization, machine learning and data mining toolkit. It features a visual programming front end for explorative, rapid, qualitative data analysis and interactive data visualization. So first of all, here this is the Orange software where we can visualize the data. Where we can visualize the data. So to visualize the data, we have to choose the pane data, and here initially it will have only the x-axis and y-axis with no data points. Here we can place our data point for clustering. This is how I can make the data points for clustering. And now the model which we are going to use is the k-means. So I'm going to place this and connect the pane data with that of the k-means. So here we can see that we can specify the number of clusters either by the fixed mode or by the variable mode. So here if I am putting it as 3 clusters, then the three clusters can be formed for the given data points. So to visualize the data, here I'm going to plot with the scatter plot. So now I'm going to connect the k-means model with the scatter plot in such a way that we can see three different types of clusters is formed. This is how the k-means is visualized by using the Orange software. So now what we have to do is we have to divide the clusters for the real data set. So for that we have to place a empty file where it contains number of inbuilt data set. So here I'm going to use a housing data for clustering, and the model what you're going to use is a k-means. So here I'm going to connect the file with that of the k-means, right? So here here we can see the housing data set can be clustered. So for that we have to fix the how many clusters we need to put, that we have to fix. And now a box plot we can use a box plot to find out the so here we can see the k value is 2, so 2 clusters are formed and the difference between the 2 data points are shown here. So now for the age data points, we can see the difference between the data points here. And to find out what type of cluster we are going to use, so for that we will use MDS, and it connect the k-means with that of the MDS. So by clicking this, we can find out the different the similarities and the group of clusters, 2 different types of clusters in the data set. This is how the data is being visualized. So the similar path will help you to find out what are the similarity between the data points. And here we can increase the size of the symbol, and also we can change the shape of the clusters. Likewise, we can visualize the data. This is how k-means can be visualized and numerically implemented. Thank you.